Okay, what's going on, guys? So today, what I'm going to talk about is the moon packet that I gave you guys to do earlier this week. I understand some of you guys are still working on it. Hopefully, this video helps you answer some of the questions that you have problems with. So I'm going to slowly go through this. If you have any questions, I'm going to post it on Google Classroom, and then we'll go from there. So for the first one, it's asking about the supermoon, which is the total eclipse. Basically, if you read the passage on number 1, it's telling you that a supermoon occurs when the entire lighted half of the moon faces Earth, the full moon phase, and the moon is the closest point. So basically, and then at the end it says the next one will not happen until 2033. So it basically is asking you, supermoon, total lunar eclipse, are events that, now the choices they give you are random occurrences. Letter B is will never happen again after 2033, are predictable, will happen every full moon. So since it gives you the date, we're able to kind of predict when they're going to happen, so they're predictable. So number 1 is going to be C, predictable. Now, number 2, it says that the time that it takes the moon to go around from its supermoon to the next full moon. Okay? So when we're talking about the supermoon, we're able to see it. So it's going to be the next phase. So I want you guys to use your notes and actually find the actual time for this, okay? I don't want to just give you guys the answers. I want you to use the notes. Number 3, the moon has more surface craters than Earth does because the moon has, now this is important. So they're talking about when you're looking at the moon, there's all these little craters that are on it, okay? So when we think about Earth science and we're thinking about when we were doing the other topics, one of the things is what usually breaks down our environment. When it rains and precipitates, we have a lot of weather and erosion. When the astronauts back in the day went on the moon, there's no atmosphere. So there's nothing that's actually doing weathering and erosion processes on the moon. So the reason why there's no basic change in the moon's surface is because it doesn't experience weather and erosion. And you need an atmosphere in order to cause that. Okay, there's no water vapor that's on the moon. It's not raining up there. So for B, for 3, it's going to be B. There's no significant atmosphere. All right, so I'll write this one up. That 3 is B. Okay. Eclipses do not occur every month because the moons. So really quick, we have Earth. Okay. And if we put the sun over here, okay, an eclipse basically is if the moon creates a shadow on the Earth, or if the Earth creates a shadow on the moon. Now, to have this happen, the moon has to be in line. But the moon does not travel along in its orbit in a perfect line with Earth. It does, however, still revolve around Earth, but it has a different projection. And that projection is more like this. So since the moon is inclined with its orbit, it's never always passing in front of the sun, or that the Earth is going to be facing it where it's going to block out and give it a shadow. So for 4, the orbit is inclined to Earth's orbit. Okay, it has nothing to do with its rotation around Earth like some of the other choices have. Number 5, the passage of the moon into Earth's shadow causes A. So there's 2 types of eclipses. So we'll go back to when we have the moon here, or if it's over here. Now, when we're talking about Earth shadow, because the sunlight is going this way. So here's all the sunlight. Now, when the moon is in front of the sun and it creates a shadow on Earth, this is called a solar eclipse. And the way to remember it is, since we're dealing with the sun and we're blocking out the sun, solar is the way to remember it, okay? Now, for the moon on the opposite side, another word that we think about moon is a lunar, okay? So it's going to be the lunar eclipse. So when the moon, in its rotation, and when it's revolving around the Earth, it goes into Earth shadow, it's going to be a lunar eclipse. And that's when the Earth's shadow blocks out the moon. So for 5, it's going to be A. Okay, so far so good. All right, so now we're going to flip it over. Now, one of the things that the moon is really important for us is because it has tides. Especially where we live by the water, we experience tides twice a day. We have 2 high tides, 2 low tides. So for the next couple of questions, they give you basically a bunch of squiggly lines that show the different tides, okay? And the date they give you is July 12th and July 13th. And it's asking you to find which one has the highest tide. So if you follow and you look up and you find which one has the highest tide, all you're going to do is you're going to follow it down, and it's going to give you July 12th at 9:10. So for that choice, it's going to be B. Based on the data, the next high tide occurred at approximately. So for this one, you have to go off of the chart. You have to think, when is the next tide going to be for the high tide? So the last high tide is around 9:30 a.m. because it says it's before noon. And you have noon over here. So now you have to think off of the board or the graph, when is the next tide going to be? So if you keep looking at the tides, you'll see that you have one tide that shows up at 9:10, like we had for the question, and then the one before that was about at 8:30. So it's slowly going up in time. So the next one, right before it goes off the graph, it shows that it's about 9:30 a.m. So the next high tide would approximately, again, remember we're doing estimates, but it's the only one that's close for a high tide. It's going to be 10 p.m. on July 13th because we haven't fully gone into July 14th yet. So the choices that say July 14th are out. So it's going to be not 10 p.m., which is going to give us choice C. Which inference about tides is best made from the given graph? So we're just looking at the graph, and we're going to see that it's a constant pattern. So that's going to give us B. That's from our first quarter quiz that we had. I believe that was the first quiz I ever gave you guys when we were making inferences and predictions. All right, it can't be A because tides don't change at random events. We kind of know when a high tide and a low tide is going to happen. And how the tides show, the high tide is always different, so it can't be C where the hourly rate of a tidal change is always the same. And the rate of tidal change is greatest at high tides because that doesn't really make sense. Number 9, the moon has the greatest effect on Earth's ocean tides than the sun because, so when we're talking about gravity and force, usually objects that are closer have more gravitational pull. The sun is larger, but since the moon is closer, it actually creates more of it affects more of the tides than the actual sun. So for 9, the moon is closer to the Earth than the sun is. And just to go through the other choices on 9, it says the sun has a higher density than the moon, but that doesn't really tell us why the moon is helping us with the tides. For C, it says the sun has a higher temperature than the moon. Temperature has no concept for this question. And then for D, it says moon has a greater mass than the sun. The moon is a lot smaller than the sun, so that can't be the answer. Okay, so now for page number 3, it gives us the Earth in the center. So I'm going to make the Earth. Then basically how the light is shown on the Earth, we can predict, or basically find out that the sun is on this side of that diagram, because the moon is a full moon over here. So all that light's going into it. So this is a full moon. Now, over here, when we see the light side is on this side, but the dark side of the moon we can't see, this is going to be the new moon. So they also give you the first quarter. And then they also give you the last quarter. So it's asking you approximately how many days occurs between the first quarter and the last quarter phase. So from this, traveling to here, traveling to here. So since we know that the moon rotates and revolves around the Earth around just under 30 days, the only choice that makes sense is that it's going to be 15 days. Okay? 7 days is too short. 7 days would be going into the full moon. 29.5 days is the actual full rotation around Earth. So that would take it from first moon or first quarter all the way around to first quarter again. So that can't be the answer if it was traveling all the way around. And then choice D gives us 365.26 days. And that is actually the time that it takes Earth to rotate all the way around the sun. So for 15, it's going to be B. I mean, 10, it's going to be B. So for 11, which statement best explains why the same side of the moon is always viewed from Earth? So the moon is a little bit different than the Earth because the Earth rotates at a faster rate than it revolves around the sun. So that's why we have night and day. The moon, however, it rotates, its period of rotation is basically the same as its period of revolution. So for 11, it's going to be D. So as the moon is going around Earth, it's rotating the same time period as it goes around. So we only see basically one side of the Earth. And that's why you always hear the dark side of the moon, because the other side of the moon is never really shown from Earth. Okay, so this next one, it gives us a diagram. I'm just going to draw it out really quick. So again, we have our Earth in the front. It says that we're looking at it from the North Pole, so we're looking above it. Okay, so we're looking down at the Earth. It shows that this side is dark. So this is basically everyone in the nighttime. This is everyone getting full sunlight. So since this side's getting full sunlight, it actually shows that Earth's rays, or sun's rays, are coming in this way. It doesn't show the sun though. Now it gives us our places for the 8 different phases of the moon. So for this, they call this 5, and we have 6, 7, 8, starts at 1, 2, 3, and 4. And because the Earth's or the sun's rays are coming in, every side that's away from the sun is dark. So just like the Earth, we're just going to put our lines going through the center of the moon, and we're going to show that all of these are in darkness, okay? And just also to show, it also gives us the pathway that is traveling. So it says, as viewed from Earth, which phase of the moon will be seen when the moon is in position 1? So position 1 right here, okay? And again, we're talking about the declination of the angle going around. So it's not going to get blocked out from the sun. But this phase where this whole part is illuminated and we can actually see it is the full moon. Okay, so it's just like the diagram I had before, but now this is the full moon. So that means the opposite side is going to be the new moon. Because we don't see it. That's when it starts up again, and then it slowly grows in light as it goes. Now it's full moon, and then it starts to wane back down to go. A way to remember this, I know some of you watched The Karate Kid. All right, you know the thing, wax on, wax off? It's starting to wax as it's getting bigger. Think of him like how he's training, okay? He's trying to get stronger. He's trying to get better at karate. So as the moon gets bigger, it's waxing. And then the other one, when it's getting smaller in the light that's shown, that's illuminated, it's waning. Okay? So that's how you can remember it. So how does the moon rotate in revolution cause the same side of the moon to always face Earth? So this is how we always had that dark side of the moon. So for 14, because they're the same, there's always a dark side facing away. So for 14, you can put something like the rotation and revolution is the same. Okay. Now, the last thing for 15, it says the circle below shade the part of the moon that appears dark to an observer in New York State when the moon is in phase 2. So New York State, we're in the northern hemisphere, so this is perfect for this because we're looking at it from basically somewhere on this side of the planet. We have to look at 2. So for 2, again, it's going from a full moon. So if it was a full moon, we would just keep that circle for 15 that they give us blank to show that it's a full moon, everything's illuminated. But because now it's starting to wane down, you're starting to get a little bit of darkness on it, okay? So the darkness that's going to go on it is going to be something like this, okay? And then if it keeps going, now you have it. If we go to 3, okay, again, this would be the answer, but if we go to 3, now it's something like this. It goes to 4. Now we're here where there's only like a sliver. And then when we go to the new moon again, now everything's blacked out and you can't see the moon anymore. And then goes to 6. Excuse me. Now you get a little bit, goes to 7. Now it's your half moon. Now it goes to 8. It's only got a little bit of darkness on it. And then you go back to full moon again. And now you're bright, okay? So these are the questions. Hopefully it helps you guys out. If you have any questions, please let me know through Google Classroom or through Remind. I'm going to post some more stuff today on the solar system. And then I'm going to give you guys a couple more questions for the weekend that we'll go over on Monday. Okay. The other thing on the sun, I'm going to be going over on Friday. So just try to get your work in. I've been, grading the stuff on Google Classroom, and I've been telling you guys if you got anything wrong and trying to explain it. I do understand that this is not the best method of teaching, but guys, just keep doing what you're doing and look at my notes or my comments that I put on anything that you get wrong, and let me know if you still don't understand it. Okay. And also for the PowerPoints, make sure you follow the links and actually watch the videos, because they help explain it when, the diagrams on just the whiteboard, since I don't have a smart board at home, can really help you guys. All right. I'll see you guys on Friday.